Hello. In this demo, we present a tool that we have developed in IBM to facilitate change impact analysis. The goal of this tool is to help developers to get a better understanding of the parts that are affected by a particular change that they're about to commit. In the following minutes, we'll describe the steps that are necessary to run change impact analysis with the tool. In the first step, we will show how a repository of a new project is added to the tool. Then, we will show how a developer can select a set of files she is about to commit and receive a recommendation list with files that should be considered before making the commit. Each of the recommended files is explained by a set of association rules along with evidence from actual commits from the repository. Finally, we will review how the developer can enter her feedback and refine the data that is used by the analysis in order to improve its future results. Let us view the first screen of the tool after the authentication is performed. In the Data Source Configuration selection screen, the developer must specify a repository of a project. The developer can either select an existing repository or enter a new one by clicking the Define New Data Source Configuration button on the top. In this page, the developer can define a new project repository. A repository can be mined from a version control system, and in this screen, the developer provides the version control information. There are three version control types that are currently supported by the web interface: CMVC, RTC, and Git. For CMVC, the developer is requested to specify the family name, username, configuration name, and the list of components and releases. The tool then connects to the CMVC server and grabs all the file changes that belong to the specified components and releases. The developer can further remove file changes by specifying developers that need to be excluded. RTC has a very similar configuration. For Git, the developer needs to specify the Git URL, the username, a configuration name, and optionally a list of Git tags to be included. The tool connects to the GitHub server and fetches all the commits that are assigned with the specified tags. If no tags are specified, all the commits are fetched. After the developer specifies the project's information, she needs to click Save and Connect to start the mining process. This step may take a few minutes, so we will skip it and run the analysis from a previously fetched project. Going back to the Data Source Configuration selection page, the tool lists the repositories that have already been defined. As you can see, there is one CMVC repository and two Git repositories. Let us focus on the Django extension project. This project is managed in GitHub. It is a relatively large project with over 2,400 commits, 4 branches, 78 releases, and 330 contributors. I have already analyzed and mined this project with the tool, so I can simply select it and choose the Use Previously Fetched Data option. Then, when I hit Commit, I get the list of files that appear in the project. From this list, the developer can choose a set of files that she is about to commit. Let's navigate the Django extension project and choose files that could belong to a possible commit. The Django extension project provides a collection of custom extensions such as management command, admin extensions, and more. Let's focus on the core parts of the project. The source of the Django extension project is stored in the Django extensions folder. In it, we can find several folders, one of which is the management folder. Let's enter it. This folder includes several files and the commands folder. This is a core folder with 44 files, which includes much of its functionality. To mimic a commit, let's choose two arbitrary files from this folder. The first file will be the graphs model. This file has a relatively large history of over 40 commits, which were made by 17 different developers. The second file is the password.py file, which was committed over 15 times and was modified by 11 developers. Let's assume that we would like to commit a bug fix which include these two files and use the tool in order to perform impact analysis assessment. So let's return to the seed selection screen and enter the two files that we want to analyze. Let's put in the model graph model file. The tool automatically generates any file or folder that has this name, and we can select it. Let's enter the second file password, and now we have defined our seed. We can set the support and confidence threshold. In this case, we'll use a support threshold of 3 and a confidence threshold of 40%. And now we can run the analysis, which will analyze the commits and generate a recommendation list for that particular seed. The recommendation list represents the top 10 files. This number was chosen as a reasonable number of files for a developer to consume. The tool indicates the confidence that it has with respect to each of the files in the indication column. This column takes 3 values: high, medium, and low. If the developer selects a file, an explanation lists the set of association rules that point to that recommended file. Let's choose the first file, export_emails.py. Now the tool presents the rules in the explanation panel. The first rule indicates that in 91% of the times that the password.py changed, export_emails.py changed as well, and this occurred in 11 commits. Second rule indicates that every time that both the graphmodel.py and the password.py files were changed, the export_email.py file was changed as well, and that occurred in 8 commits in the history of file changes. By selecting the Show Me the Evidence button, the developer can view the actual commits from which the rule was derived. For example, if we select the first rule, then we get the list of commits that included the files of export_email.py and password.py. And we can actually see the entire list of files that each of those commits included. After investigating the commit, the user may decide that some commits need to be modified. For this, we define the configuration of exclusion rules, which can be defined by clicking the Configure Exclusion Rules button. To generate an exclusion rule, the user can select the dedicated button. Exclusion rules are regular expressions that are used to filter file changes. Currently, we support 2 types of exclusion rules, ones that are based on the path name and ones that are based on the author name. The condition states in which cases the file change will be filtered. We have the starts with, ends with, contains, or equals, and then we can enter a specific value. So let's try to filter the file that was listed first in the recommendation list that we have just seen. I'll edit as the value, and let's choose equals and the path name. We save and continue, and now, since we have the same seed, we can rerun the analysis. We select Analyze, and as you can see, the file was filtered out. The user can continue and refine the data that is used to derive the rules of different recommendations with additional configurations that he can add, remove, and choose. We're done presenting most of the functionality of our tool. We intend to extend it by adding other version control and issue tracking system and supporting a wider range of exclusion rules. Thank you for your attention. Goodbye.